So this one I'm going to read. This is the diagram below, not drawn to scale, shows the journey of a ship which started at P, 15 south. So from P, this is 15. That's what they're saying. 15 kilometers. And it come to Q. So you need to put Q here. See, I label as I go in. So I am at P, and then I came down south 15 until I reach Q. So I write Q there. So it's based on the information that I'm labeling from, nothing else. So we came down to Q. Then now it says, and further 20 due west. So what this is R. So basically, and this is 20. So they wanted to do this now. Copy and complete and label the thing. So we label it to put on the Q, put on the R, and you put on the two distances. Then give you 2 marks to do that. What we did, 2 marks is already there to follow from, and they start you at P and they tell you. So you're following from your P, you come down to Q, and then you go across to R. You just keep putting on your labels and so on and so forth. Collect your marks, you get 2 marks for that. The question says, calculate PR, the shortest distance of the ship from the port where the journey started. So we close that triangle right there. So when we close that triangle now, they ask for PR. So you're seeing that, oh, it's a right angle triangle because this is a right angle. I have this distance. I have that distance. Whatever they ask, you're going to find it. Now, what concept in mathematics that we did in this class now can allow us to find this side from P to R? Based on what they give.
Tan, sir.
You have adjacent and opposite.
All right, can I ask you a question? Who said that? Jody?
Tan, when I said tan, sir?
Yeah. Talk to me now. We're going to talk. Don't close your mic. We want to talk. All right, so I'm going to ask you a question. What side is opposite and what side is tangent? And what side is adjacent? Wait, Shakira, let me talk to Jody for a minute. Soon come to you, Shakira.
20 would be adjacent.
Adjacent. Wait, don't rush it. Adjacent to what?
The R, sir, the under right here.
Oh, I agree that it is adjacent to R, but is R in the question right now? Like what they want you to find. All right. What is it that you want to find, Jody? Because I think you're not sure what you want to find. Are you trying to find an angle, or is it that you're trying to find the length of a side? Jody?
The length of a side, sir.
If you're going to, you smile, you realize now that the reasoning won't work for that, right? Because if you're going to find the length of a side and you have 2 sides already and it's a right angle triangle.
It will be AB squared plus B squared equals C squared.
Shakira, I preempt that you were thinking along that line.
Yes, sir. I was thinking the same thing.
Exactly. So we're thinking now of the Pythagoras, right? Theorem. Exactly. So this is the thing with the questions. They will have you doing so many things that when you come to a simple thing, you're still in a mode of doing something else. Remember how I said I want you to scan. First, I want you to look on the situation that you have. See what is given, see what they want. That will tell you what to choose. Because, Jody, you see, as long as they did not give me an angle, or if they're not asking me to find an angle,
yes, sir,
trig ratios cannot work. Trig ratios only work when they give an angle or they're asking you to find an angle in a right angle triangle. If they're not asking those, trig ratios don't work. The only thing that works when you're given 2 sides of a right angle triangle to find the third is Pythagoras theorem. Nothing else works. The only thing could work is you would measure the thing on the ground and really take a tape measure and measure it for real. Of which you're not going to measure any 15 or anything right now. But I'm just saying, if you're not going to measure it physically, it's the Pythagoras theory that you need to ride this one out. Let's go for question number 2. Start off with the long side square. The long side is PR. So we want to say PR square is equal to 15 square plus 20 square. So the long side square is equal to the sum of the two short side square. 15, this is 225. This is 400. This is 625. I think the answer is 25. This looks like 25. Anybody talk to me?
Sir, I don't understand how you 15 squared plus 20 squared.
Yeah. Oh, I'm going to ask you a question and open back your mic, the person.
Yes, sir.
You missed out. How many classes you missed? That's the question.
Sir, I didn't miss it, but sir, because like I thought we are trying to find P.
No, they didn't say that. Read this. Let me highlight it for you.
Calculate PR, the shortest.
PR. Hold on. Slow down back. Go back. Calculate PR. PR is a distance milligauge. Distance.
Yes,
they don't have to tell you the word distance, but matter of fact, they said it. They said the shortest distance there, but they don't have to tell you. The moment you have two different letters, just two letters from one point to the next, it's a distance. Right now, there's an imaginary distance between where you are and where I am right now.
Yes, sir.
And it's called MW. You understand? Wendell milligauge. Connect with that imaginary line. So that's it, man. So we decided that it's Pythagoras theory that we're going to use. And this side that they asked us for is the hypotenuse side. So the longest side square. Remember that now?
Yes, sir.
All right, good. So you have to pay attention to all the details. So this answer here is 25. Go ahead. Go ahead. I'm listening.
Say that PR is the shortest distance. How is it that?
Huh? No. Hold on. The shortest distance has nothing to do with the triangle that was formed. Don't mix up anything. Watch this. PR is the shortest distance. Look, from what? Port. From port, where the thing started. Let me help you out. Do you know that the shortest distance between any 2 points is a straight line? You know that?
Yes.
That is what they're saying here indirectly. For example, you started your journey at P and you find yourself at R. The shortest distance between P and R is a straight line, which I put there. That doesn't mean that it is the short side of the triangle. That's a different argument. Make sense?
Yes, sir. Yeah.
All right, very good. At least you're picking up things and you're querying it, which is good.
Sir.
Go ahead.
Sir, in what case do we do, like, for instance, you would have 15 squared plus 20 squared, and would have minus 2, and would have 50 in bracket 15 times 20, and would have like 10.
Okay, all right. Let me tell you where you're going now. That's the topic that comes after this, and it is called trig rules. Trigonometry rules. And that's when we don't have right angle triangle and things are happening. What do we do? But we're not going to discuss it yet, but we're going there when this is done. That's where we're going. Trig rules, but that is after trig ratios. All right? All right, good. So we soon go there. If not at the end of the class, depending on how many of these we get to do, it will be the first thing the next class. I can tell you. All right. So we use the Pythagoras theorem. We got with 25. Everybody, we okay with the 25 idea you're seeing how it popping out of your triangle? All right. All right. Here's a question now. Calculate the measure of angle QPR to the nearest degree. See now, the moment they ask me about an angle, Jody, that's when I'm thinking trig ratios now in the right angle triangle, QPR. The issue is you must label the angle. You're moving from Q. Can I clear up this diagram first, by the way? Let me take off all of this. All of these, I want to take them off so that the triangle is clear. Taking off the things that we're not using now. All right. So we're talking about QPR. You're going to move from Q to P to R. The angle is always in the middle of the three letters. Q to P to R is this angle up here. Everybody agree? Q to P to R. Q to P, then to R. So the angle is at P. Of course, you can find an angle. You know that all the rules can work though, because you have the three sides. So whenever you have three sides of a right angle triangle, you can use all three ratios and get the answer. So nobody is supposed to say they don't know what to do here, because every one of them can work because you have all the sides of the triangle available to you. So let me work this one to this side. Right there. All right. So we're talking about having that angle up here. I am going to just pick on one. Remember that is so, ka, tower. And I'm saying I can use anyone because of the information that I have. So let us say I decided that I want to use sine. If I am going to use sine, I have to set up opposite with hypotenuse. And it can work. So sine of the angle that I don't know yet is equal to the opposite over that. Solution 1. Solution 2. I could say cos of that same angle is the adjacent. The adjacent is, boy, this diagram is going to get ugly each time I write, okay? But I guess everybody knows about those stuff.
Number 15, sir.
Yeah. So
And
I'm just saying the diagram might get ugly. So it will be the adjacent over hypotenuse. To say tangent of that angle is 20 over 15. I'm just going to use one of them. So I'm using number 1 right now. Sine of the angle is 20 over 25. Look like about 0.8. I don't know. Well, it looks like that.
Yes, sir, 0.8.
Good. So then we're looking at the sine of the angle is 0.8. So the answer is sine inverse of 0.8. And I'm getting some 53 point.
1.
But they said to the nearest degree. So let me write the answer now. So I'm going to write angle Q P R equal 53. Because remember, they did say to the nearest degree. So when they do that, don't just give what you want. Yes, we get 53.1, but they want the nearest degree. It's 53 flat you have to give.